Good day, everyone. You are welcome back to ID International Academy Mathematics class. Before we go into today's work, let's have the solution of our last class assignment. This is question number 1 in the assignment. Solve x squared minus 2x in bracket raised to power 2 equals 384 over cube root of x. How do you approach this? X squared minus 4x squared, 2 squared is 4, x squared is x squared, equals 384 whole over x raised to power 1 over 3. Cube root is interpreted in power as power 1 over 3, So x squared minus 4x squared gives minus 3x squared, which is equal to 384 whole over x raised to power 1 over 3. The next thing to do here is to cross multiply for easy process. So if this is over 1, cross multiply x raised to power 1 over 3 times minus 3x squared. We have minus 3x squared times x raised to power 1 over 3 equals 384. Looking at it, you can see that when we divide both sides by negative 3, it will be easier. So we divide both sides by negative 3. We have negative 3x squared plus 1 over 3. I use the opportunity to simplify this. This and this is x is the common base here. We pick one of them and we change multiplication to addition in the exponential region to operate the power 2 and power 1 over 3 together, which is equal to 384. So we divide this side by minus 3. We divide this by minus 3. So this will give us x raised to power 2 number 1 over 3, which is equal to minus 3 in 3, 1. 3 in 8, that is 2, remains 2. 3 in 24, that is 8. Do you understand? So we have x raised to power 7 over 3. How? 3 times 2 is 6 plus 1, 7 over 3, which is equal to minus 2 raised to power 7. Minus 128 could be expressed in index form as minus 2 raised to power 7. To resolve this perfectly, we find the reciprocal of the power of the unknown. The power of the unknown there is 7 over 3. The reciprocal will be 3 over 7. It is that reciprocal we use to multiply the powers on both sides of the equation. So we have x raised to power 7 over 3 times the reciprocal of 7 over 3, which is 3 over 7, equals minus 2 in bracket raised to power 7 times 3 over 7. 7 we take out of 7, 3 takes out of 3. We have x raised to power 1, which is equal to 7 cut 7 here. We have minus 2 raised to power 3. X raised to power 1 is x, which is equal to negative 2 raised to power 3 gives negative 8. Why negative 8? Whenever you raise a negative value in even power, when I say even power, power 2, power 4, power 6, power 8, and so forth, those are even power, even indices. The negative value that we raise in any even power will give us positive answer at the end of the day. But when a negative value is raised in odd power like power 1, power 3, power 5, power 7, and so forth, such negative value that we raise in any odd power will give us negative at the end of the day. That is why negative 2 raised in power 3. Power 3 is odd power. Raised in power 3 gives us negative 8 back. And that is the end of that question 1 in the assignment. Let's have the solution to question number 2. Solve 2 raised to power x over 2 times 1 over 4 in brackets raised to power x divided by 8 raised to power x plus 1 equals 64. This is 2 raised to power x over 2 times 2 raised to power negative 2 into x divided by 2 raised to power 3 into x plus 1 equals 2 raised to power 6. 64 could be raised on 3 different base numbers. It could be raised on base 2 as this. It could be raised on base 4. It could be raised on base 8. But when you observe that base 2 is the common thing and the only obtainable root or base number here, so you express 64 as well as a number raised on base 2. Do you understand? So this is 2 raised to power x over 2 plus this multiplication changes to addition in the exponential region as negative 2x minus, it is this division sign that changes to this subtraction in the exponential power area. So as 3x plus 3. I opened this bracket already, but I put this bracket because of the negative sign here, which is equal to 2 raised to power 6. So this is 2 raised to power x over 2 plus times minus is minus 2x. Using this negative sign to open this bracket, we have negative 3x negative 3, which is equal to 2 raised to power 6. We see that we have equal bases on different sides of the equation, which suggests that the powers on both sides are also equal. So the powers on this side is this long jargon. So you write it x over 2 minus 5x minus 3, because minus 2x minus 3x is minus 5x. So with this minus 3, which is equal to 6. The power on the other hand, 6. The power here is this long jargon. So you equate them together. This, we can have x over 2 minus 5x equals 9. That is, I collect the like terms. I take negative 3 to the other side to meet figure with figure, and algebraic terms with algebraic terms. So we have this. Clearing the fraction. We use 2 to clear the fraction here because 2 is the LCM of the fractions in this fractional equation. So we use 2, which is the LCM, to multiply each term. We use to multiply the term x over 2. Also, the term minus 5x, we use 2 to multiply it. The term 9, we use 2 to multiply it. 2 we cut through here to have x. Minus 5x times 2 here will be minus 10x, which is equal to 18. 9 times 2. X minus 10x gives minus 9x, which is equal to 18. We divide both sides by the coefficient of x. The coefficient of x there is negative 9. Dividing both sides by negative 9, we have negative 9x divided by negative 9 equals 18 divided by negative 9. So we have x equals negative 2. And that is the end of question 2 in the assignment. Solution to question 3 in the assignment. Solve x raised to power 0.2 divided by x raised to power 3 equals 5 raised to power negative 5 whole number 3 over 5. Well, x raised to power 1 over 5 is another way of writing 0.2. 0.2 is 1 over 5. When you convert it to fraction, minus 3 equals 5 raised to power negative 5 times 5, 25, plus 3, 28 over 5. Are you following? Now, x raised to power negative 2 whole number 4 over 5. Resolving 1 over 5 minus 3 gives you negative 2 whole number 4 over 5, which is equal to 5 raised to power negative 28 over 5. Converting this power to improper fraction, we have x raised to power negative 5 times 2, 10, plus 4, 14, negative 14 over 5, which is equal to 5 raised to power negative 28 over 5. To resolve for x, finally, we find the reciprocal of the power of that x. The power of the x is negative 14 over 5. The reciprocal of that power is negative 5 over 14. That negative 5 over 14 will be used to multiply powers on both sides of the equation. Thus, x raised to power negative 14 over 5 times negative 5 over 14, which is equal to 5 raised to power negative 28 over 5 times negative 5 over 14. 14 will take care of 14. 5 will cut 5. Negative times negative gives positive. So all in all, we have x raised to power 1, which is equal to, here, 14 in 28 gives 2. 5 cuts 5. Negative times negative gives positive. So we have 5 raised to power positive 2. Do you understand? Let me take it all again. 5 goes in 5 one time. 14 goes in 14 one time. 14 goes in 28 twice. All in the power area here, we have only figure 2 left there. Negative times negative is positive. So we have positive 2 as the power left there. So we have 5 raised to power 2. Don't forget, x raised to power 1 is tx. And 5 raised to power 2 is 25. And that is the solution. Let's go to solution of question 4 in the assignment. Solve 18 over 50 in bracket, all raised to power x minus 1, which is equal to 1 over 25 over 27 in bracket, all raised to power negative 1 over 3. To start with, 18 over 50 could be simplified. So we simplify it as 2 goes in 18 9 times, 2 goes in 50 25 times. So we have 9 over 25 raised to power x minus 1, which is equal to, remember the law of negative index. 1 over 25 over 27 will become 27 over 125 raised to power 1 over 3. The negativity will disappear because we have found the inverse of the number. 9 over 25 could be raised in index form. How? 3 square over 5 square raised to power x minus 1, which is equal to, also this could be raised in index form, 3 raised to power 3 over 5 raised to power 3, all raised to power 1 over 3. The power of the numerator and the denominator are the same. So we can have a common power as 3 over 5 raised to power 2, that is common to them, into x minus 1 equals The same thing here. Power 3 is common to both numerator and denominator. We have 3 over 5 raised to that common power 3 times 1 over 3 that has been existing there before. Looking at this equation critically, you remember this law of common base in the equation of indices. Once we have common base, then the powers are also the same. The base 3 over 5 here is the same base 3 over 5 here. Therefore, 2x minus 2, the expansion of this, is exactly equal to 1, the simplification of 3 times 1 over 3. 3 times 1 over 3 is 1. So this is the 1. Collect the like terms. Collecting the like terms, we have 2x equals 1 plus 2. Bring the negative 2 across the equality sign, changes its sign to the positive. So we have 2x equals 3. The value of x here is gotten by dividing both sides by 2. So we have 2x divided by 2 equals 3 over 2. So x equals 3 over 2, which is 1.5 or 1.5. Do you understand? The last question in the assignment. Solve 3x raised to the power 4 equals 24x. It looks somehow closed. When an uninformed student first sees a question like this, such a student will think this question it looks so closed, as if there is no inroad into it. There are a lot of inroads. Divide both sides by x first. Divide both sides by x. So, you have 3x raised to the power 4 divided by x equals 24x divided by x. And that gives us 3x raised to the power 3, which is equal to 24. Next to that, divide both sides by 3. So we have 3x raised to the power 3 divided by 3 equals 24 divided by 3. This gives x raised to the power 3 equals 8. You can see that the way is just opening on its own accord. Once you take the right step, the way will begin to open. Here you have 2 or 3 ways of doing this. As from this level, you can have x raised to the power 3 equals 2 raised to the power 3. Don't forget, once the powers are the same, you can conclude, therefore, x is equal to 2. Once the powers are the same, then the bases are also bound to be the same, so x is equal to 2. Or from that juncture, you say x raised to the power 3 equals 8. You take cube root of both sides. Cube root of both sides. This will cancel this. We have x. So cube root of 2 raised to the power 3. X will be equal to 2 because this also will take care of this. Or you can say x raised to the power 3 equals 8 is x raised to the power 3 times 1 over 3. The power of the unknown here is 3. The reciprocal of 3 here is 1 over 3. If you use that 1 over 3 to multiply the powers on both sides, you get the same thing. So the reciprocal of 3 is 1 over 3. Use 1 over 3 to multiply the power here and also the power here. But in that case, you express 8 in index form to have the power. So you have 2 raised to the power 3 times 1 over 3. So which gives x equals 2. 3 we cut 3 here, leaving behind 2 raised to power 1, which is equal to 2. Also, 3 we cut 3 here, leaving behind x raised to power 1, which is equal to x. And that is it. You have 1, 2, 3 ways of doing the same thing. So we can now easily move into the next work of the day. So today's work is exponential equation 2. Here we are going to dig deeper in exponential equation, different from what we dealt with in exponential equation 1. Altogether, they are not also difficult. I mean, the concepts here also are not difficult, but they are a bit deeper than the one dealt with in exponential equation 1. So, example 1. Solve 2 raised to power x plus 3 minus 2 raised to power x equals 56. Deal with this by reversal. You have 2 raised to power x times 2 raised to power 3, a way of reversing it, minus 2 raised to power x equals 56. 2 raised to power 3 is 8. 8 times 2 raised to power x is 8 into 2 raised to power x minus 1 into 2 raised to power x. That's another way of writing this to make it more clearer to a layman. Equals 56. So, subtracting 1 of it from 8 of it, you have 7 of it. 7 of 2 raised to power x, which is equal to 56. Dividing both sides by 7, you have 7 into 2 raised to power x divided by 7 equals 56 divided by 7. Are you following? So this cuts this to half. 2 raised to power x equals 8. 56 divided by 7 gives 8. So 2 raised to power x is equal to 2 raised to power 3. 8 is 2 raised to power 3. Therefore, x equals 3. Equal power are equal base. Equal bases means equal powers. That is the end of that. Now the end of example 1 under this. Example 2. Solve 3 raised to power 1 plus x plus 3 raised to power x equals 12. Reverse this to be 3 raised to power 1 times 3 raised to power x. Resolving this, simplifying this, will give us this back. Plus 3 raised to power x equals 12. 3 raised to power 1 is 3. 3 times 3 raised to power x, we have 3 into 3 raised to power x. Plus 1 of 3 raised to power x. Rewriting 3 raised to power x as 1 of 3 raised to power x is the same thing for more clarification. Equals 12. So, adding 1 of it to 3 of it, we will have 4 of it, which is equal to 12. Dividing both sides by 4, we have 4 into 3 raised to power x divided by 4 equals 12 divided by 4. This cuts this to give us 3 raised to power x equals 3 raised to power 1. 12 divided by 4 is 3. But 3 in index form is 3 raised to power 1. So, looking at this, we have common base on different sides of the equation, meaning that their powers also are the same. X is equal to 1. Simple.